Good day, everyone. Myself, Anutama, and I am going to explain on the topic speed control of three-phase induction motors. First, let us see what is meant by speed control. In three-phase induction motors, speed control is not that easy. A three-phase induction motor is basically a constant speed motor, so it's somewhat difficult to control its speed. The speed control of induction motor is done at the cost of decrease in efficiency and low electrical power factor. Normally, the speed of induction motor is given by n is equal to ns into 1 minus s, where n is the speed of rotor of an induction motor, ns is the synchronous speed, and s is the slip. There are many techniques to control the speed of an induction motors. Let us see some of the methods. They are pole changing method, stator voltage control, supply frequency control, eddy current coupling, rotor resistance control, and finally slip power recovery control. And I have taken the topics pole changing method and stator voltage control. Let us see in deep these two methods of how to control the speed of an induction motor. First, let us see about the pole changing method. Pole changing method is one of the main methods of speed control of an induction motor. This method of controlling the speed by pole changing is used mainly for cage motor only because the cage rotor automatically develops a number of poles which is equal to the poles of the stator winding. The number of stator poles can be changed by the following three methods. They are multiple stator windings, method of consequent poles, and a method which is usually called as PAM, that is pole amplitude modulation. Let us see these three methods one by one. The first method is multiple stator winding method. In this method, there are two windings that are provided on the stator which are wound on the two different number of pole. One winding is only energized at one time. Let us consider there are two windings for 6 poles and 4 poles. If the frequency is 50 Hz, the synchronous speeds will be 1000 and 1500 revolutions per minute respectively. This method of speed control is normally considered to be less efficient and it's also more costly. So, this method is only rarely used. Let us see the next method. The next method is method of consequent pole. In the method of consequent poles, a single stator winding is divided into few coil groups. The terminals of all these groups are brought out. By simply changing the coil connections, the number of poles can be changed. In practice, the stator windings are divided only in two coil groups. The number of poles can be changed in the ratio of 2:1. As I said, in practice, the stator windings are divided only in two coil groups that can be seen in the next diagram. In this figure below shows that there is a single phase of a stator winding which consists of 4 coils. These are the 4 coils, and these are divided into 2 groups, that is 1 and 2 and 3 and 4. They are named as A, B, C and D. A comes from phase 1 and B goes to phase 3. Similarly, C comes from phase 2 and D is connected to phase 4. These are connections for the 4 poles. Let us see the last method, that is pole amplitude modulation. Pole amplitude modulation is a flexible method of pole changing which can be used in application where speed ratios other than 2:1 are required. The motors designed for speed changing based on the pole amplitude modulation scheme are known as PAM motors, that is pole amplitude modulation motors. That is all about the first method of pole changing. Let us see the next method, that is stator voltage control. From the name itself, we can infer that stator voltage control means controlling the voltage that is provided on the stator side. By controlling this voltage, we can control the speed of an induction motor. Stator voltage control is a method used to control the speed of an induction motor. The speed of a 3-phase induction motor can be varied by varying the supply voltage. Slip at the maximum torque is independent of the supply voltage. The variation in the supply voltage does not alter the synchronous speed of the motor. This is the torque speed characteristics of an induction motor. In this graph, the x-axis is taken to be speed and y-axis is taken to be torque. There are 3 graphs that is drawn for V1, V2 and V3. This shows the fan load. In this diagram, we can infer that V1 is greater than V2 and V2 is greater than V3. Let us see the methods how to control speed using stator voltage control method. By varying the supply voltage, the speed can be controlled. The voltage is varied until the torque required by the load is developed at the desired speed. The torque that is developed is proportional to the square of the supply voltage and current is proportional to the voltage. Hence, to reduce the speed for the same value of same current, the value of the voltage is reduced and as a result, the torque developed by the motor is also reduced. This stator voltage control method is suitable for applications where the load torque decreases with speed. For example, in the fan load. This method gives a speed control only below the normal rated speed as the operation of voltages if higher than the rated voltage is not admissible. These types of drives require low torque at low speeds. This condition can be applied by applying lower voltage without exceeding the motor current. The variable voltage for speed control of small size motors, mainly for single phase, can be obtained by the following methods given below. These can be done by connecting an external resistance in the stator circuit of the motor or by using an auto transformer. We can also use a thyristor voltage controller or by using a triac controller. Let us see some of the other methods how to control the speed of an induction motor. As I said in the previous slide, we can use an triac controller, and in this I am going to explain how to control the speed by using an triac. A speed control is obtained by varying the firing angle of the triac. These controllers are known as solid state fan regulators, as the solid state regulators are more compact and efficient as compared to the conventional variable regulator. Thus, they are preferred over normal regulator. In the case of three-phase induction motor, three pairs of thyristor are required which are connected back to back. Each pair consists of two thyristors. The diagram below shows how a stator voltage control of a three-phase induction motor by using thyristor voltage controller is done. In this, you can see the thyristor which are connected back to back. We said there are three pairs and each pair consists of two thyristors. Here comes the three-phase AC supplies which is given to both the thyristors, and this will be fired during the on cycle and another one during the off cycle. These three are again connected to an three-phase induction motor. And let us see the procedure how to control the speed. Each pair of thyristor control the voltage of the phase to which it is connected. Speed control is obtained by varying the conduction period of thyristor. For low power ratings, the back-to-back thyristor pairs connected in each phase is replaced by triac. And that is all about the techniques of speed control of three-phase induction motors, and in detail I have explained the pole changing method and stator voltage control methods. There are also many methods in which the three-phase induction motors can be controlled. Thank you.